Okay, this is your second video for solving systems of equations using elimination. Okay, there are some times when you may get a systems of equations where you are not able to eliminate one of your variables using just addition or subtraction. Okay, there might be times when you're looking at it, not only do you not have coefficients that are the same, okay, that are the same number, or they might not be opposites, okay? These times you'll have to take an additional step before you can add or subtract. Okay, there are times you're going to have to use multiplication or division. Okay, so let's look at an example so we have kind of an idea. I have a systems of equations here. Our first one is x plus 3y equals 10, and our second one is 3x plus 2y equals 9. Okay, in this system, if I look at my coefficients of my x's, I have a 1 and a 3, okay, which are not the same number, nor are they opposites. And if I look at my y's, I have a 3 and a 2. Same thing, they are not the same number, and they are not opposites. Okay, so I want to find a way that I can eliminate a variable. Okay, I like to set it up so I have opposites. I like to find ways, or if I have a 3x here, my top equation, for example, would have a negative 3x. Okay, so let's look at that. How could I get something from a 1x to negative 3x? Remember when we were talking about functions and you have to go through a transformation? Okay, how could I transform 1x to negative 3x? Good. I would have to multiply this first part by negative 3. Okay, if I did that, I would start to be able to eliminate my equations. Okay, eliminate a variable. So, since we want to change our first number to negative 3, we have to multiply this entire equation by negative 3. Okay, we're going to use our distributive. So, we need to multiply all parts of our equation by negative 3. Okay, what is 1x times negative 3? We have negative 3x. What about 3y times negative 3? We have minus 9y and negative 9y. And it's going to equal 10 times negative 3, which is negative 30. Okay? These two equations are equivalent. X plus 3y equals 10 is equivalent to negative 3x minus 9y equals negative 30. Okay? It's the same thing. We have just changed it up a little bit. So our second equation, we're going to keep the same. So I'm still going to have 3x plus 2y equals 9. Okay, now I can set this up as an addition problem, right? I have opposites now. I have a positive 3x and a negative 3x. Okay, if I set this up as an addition problem, I'm going to be able to eliminate my x's. Now I have negative 9y plus 2y equals negative 7y. And then negative 30 plus 9 is going to be negative 21. Okay, if we divide by our coefficient y, we get that y equals 3. Okay, it's the same process from here. We're just plugging our y back in to solve for x again. So let's go to our second equation this time. Why not? 3 times x plus 2 times our y, which is 3, equals 9. 3x plus 2 times 3 is 6 equals 9. How do we get our 6 to the other side? Should be drilled into your heads by now. You do the opposite. Okay, we get 3x equals 9 minus 6, which is 3. And our x is going to equal 1. Okay, if I wrote it as an ordered pair, I would have a solution to my systems of 1, 3. Remember, you can always go back to check this. Okay, so using multiplication, you add a step before you do your elimination process, before you can add or subtract your equations. Okay, let's look at another example. Again, if I went and just set this up as a regular addition problem, I'm not going to eliminate either of my variables, am I? If I did this as an addition problem, I end up with 6x plus 5y plus 34. Okay, so we're going to have to multiply one of our equations so that we can do an addition problem that will eliminate a variable. Okay, I say look at both your x's and look at both of your y's. Okay, is there one where you can easily multiply it by a number to eliminate it? Okay, if I times 2y by number, would I get it to 3y or negative 3y? Okay, I could, it's going to be a fraction, right? So maybe we should look at our x's. Okay, I have 5x and I have 1x. Is there a number I can multiply one of my equations by that I can set it up for elimination? Good, if I have a positive 5y, I think that I can multiply this second equation by negative 5. Right? Because negative 5 times 1x is going to make negative 5x. And I know that negative 5x and positive 5x are opposites that we'll be able to eliminate. So my new equation here, if I multiply the whole thing by negative 5, we said it's going to start with negative 5x. What's negative 5 times 3y? Good, negative 15y. And that equals negative 5 times 10, which is negative 50. Okay, and our first equation up here just stays the same. I still have 5x plus 2y equals 24. Okay, so now it's just an addition problem like we were doing the other day. Okay, 5x plus negative 5x is going to cancel. Those will eliminate. Then I have positive 2y plus negative 15y. And I get negative 13y equals 24 plus negative 50. You know what that one is? It's negative 26. Okay, if I divide by my coefficient of y, what is negative 26 divided by negative 13? Good, y is going to equal 2. Okay, let's pick an equation to plug it back into. We look at our original equations here. I think that we should try our second one. Okay, we're going to have x plus 3 times, well, 2, because 2 is our y, equals 10. Or we have x plus 6 equals 10. If we subtract 6 from both sides, you get that x equals 4. Okay, your new solution to your systems is the point 4, 2. That's our x, y. Alright, there's one more example. Sometimes instead of using multiplication, you might have to use division. Okay, it might be easier to use division before you do your addition or your subtraction problem. Okay, if you look at your x's and you look at your y's, are there ones that look like they are divisors of each other? Good, a 2x and a 4x. It looks like I can divide 4 by 2 to get another 2x. Okay, so I'm going to divide this entire second equation by 2. Okay, all parts of my equation are going to be divided by 2. When I do that, what do I get? What is 4x divided by 2? I'm going to have 2x. What's 8y divided by 2? Get a positive 4y. And 18 divided by 2 will equal 9. Okay, and our first equation hasn't changed, so we still have up here 2x plus 3y equals 15. Hey, look closely at your variables. Do we have coefficients that are opposites in this case? Do I have something that's a negative 2 and a positive 2, or a negative 7 and a positive 7? Okay, I don't think so. It looks like we have coefficients that are the same number, right? 2x and 2x. So we need to subtract our second equation. Okay, Okay, so let's look at this as a subtraction problem. 2x minus 2x is going to cancel. Okay, what's 3y minus 4y going to equal? Okay, that's going to be a negative 1y. And what's 15 minus 9? 6. Okay, if we divide by our coefficient, y equals negative 6. Same thing, let's plug this back into an original equation. Okay, we'll do our first one up here. 2x plus 3 times negative 6 equals 15. Okay, 2x plus 3 times negative 6 is negative 18 equals 15. If you add 18 to both sides of our equation, we are going to have 2x equals, what's this going to be? Look closely. Good, 33. Okay, and x will equal 33 halves. Okay, but I wrote this as an ordered pair. It's the point 33 halves, comma, negative 6. All right. This is your second video on elimination using multiplication and division.